let us look at element. So the one that I listed just now was the element of the mechanical element or mechanism. So example that I show here is that rack and pinion can be used to convert rotary motion to linear motion. So when you talk about mechanism, normally it's something that you want to change the motion, either to transfer the motion from rotary to rotary, or from rotary to linear, or from linear to rotary. So how you want to transfer the motion depending on the setup that you are using. So example of mechanical element you can see here in the first figure is crank rocker parallel. This is example of a 4-bar link. And the second one is a gear type, which is the spur gear. Third one is the belt pulley or parallel gear. A belt pulley. So belt pulley, where does that pulley commonly used in daily life? Anyone?
Bicycle.
Bicycle, no. Bicycle, no. Bicycle using timing belt. Using this lebih kurang macam timing belt lah kan. Bicycle belt and pulley ke? You have a gearing, right? You have something like the teeth, right? So it's not belt and pulley. Belt pulley is just a belt. So belt. Example in a production system. Okay, you have a conveyor kan? Conveyor moving. So that conveyor belt normally have the belt pulley motion. So it's going to pull the conveyor. Okay, thank you. Siapa tanya jawab tadi Alright. Cam and follower. Okay, this I share to you in Telegram. Cam and follower. Example of cam and follower. Okay, so one example was in an engine. So later we are going to look into that example and why I actually share in Telegram lots of example of engine. V6 engine. If you see there, we have lots of engine. The common one is the 4-cylinder engine. The common one, 4-cylinder. But of course, the one that higher end means that sports car, they have the V8 engine or V6 engine. So V6 engine is that the engine is look like this. And we have, if you look to the video, another one is that the inclined 6-cylinder engine means that parallel. Alright? So, not parallel, in series. So this is where later on you will look at all of this mechanism are in, and it actually can be found in your car. Then we have rack and pinion. The rack and pinion. Where can you actually see, or where do you think rack and pinion is being used? Anyone? From the video? Any? Okay. That one is sprocket and chain. So sprocket and chain, you can find it in your bicycle. Okay, bicycle, you have the sprocket. Sprocket is the one that have the tooth lah. Okay, that one is sprocket. And then the chain is the one that is going to move. Because if you don't have the sprocket and chain, then there's no grip on the sprocket. So that's why a sprocket and chain is used in bicycle. And of course in your motorbike also. In your car, it's not using pulley, but it's using timing belt. Okay. So these are the few of example, but we are going to go into detail later on. So mechanism, what is the definition of mechanism? So mechanism is a system of rigid element. This is comprised of linkages. Linkages. What is linkages? So this is linkage. Okay. One tube like this is one linkage. Arranged and connected to transmit motion or force in a predetermined fashion. So it means that it's a motion converter. It converts either from linear motion to rotary motion. So it transmits motion or transmit force. So those are the main definition of mechanism. Okay, so mechanism is a heart of machine which consists of linkages and joint. So for example, engine mechanism. So this is where I show to you the example of crank and slider. Or in an engine, it's called crankshaft. Crankshaft. So if you saw the video just now in the beginning of at 8, just now I played the video of the engine, the crankshaft with the cam and follower. So it actually transforms linear motion into rotary motion. Okay, and also vice versa. Okay, at the beginning of the engine, when you start the car, what happens that this rod will start to move, you start to rotate, and what happens when it start to rotate, this is going to rotate, and this slider, okay, connecting rod, this slider, we call it slider because it's moving in linear motion. So anything that moving in linear motion, you can either call it a slider also. So the slider will be moving up and down, up and down. So it's going to translate or convert from rotary motion to the linear motion. Okay, so when you start your engine, what happens that it's going to rotate and this slider will move up. Okay, at this point is that air is being sucked into this compartment. Okay, and when it rotates again, it's going to push, slider going to push back, push up, and where the air will be going to compress, air and fuel will going to compress here, and the spark plug will actually ignite and burn, means that burn the fuel, means that give the energy will explode, not explode like an explosion, but explode inside this compartment. And what happened, that explosion actually moved the slider down again. So that is where this definition is given, where it transforms linear motion into rotating motion. So the first initial point only is start to rotate, and after that, this linear motion actually give the rotation to this crank. Okay, it's going to move, right? So converting linear to rotary motion, and based on this, this is where this actually crankshaft will be connected to your by gear connected to your gears, to gear, and then to your the wheel shaft. So that's where your car can rotate, right? So this is the basic idea behind the crankshaft, and this is example of crank and slider mechanism. Okay, so the mechanism can still be used to provide such functions. So it either can you can either want it to make a force amplification, for example, by levels. So you want to use rack and pinion to actually improve the force. You can either change speed by gears. So you can either use parallel gears, bevel gears, okay, or connected the gears in parallel, and transfer of rotation. So it's either you want to transfer rotation rotary to rotary, rotary to linear, and so on. So example is spinning belt is example of rotary to rotary, and belt chain is also rotary to rotary. Okay, so kinematics is actually the study of motion with regard to forces. So, but in this topic, you're not going to get about more on the kinematic. Later on, you will have a subject on kinematic and dynamic. Okay, this is where you will learn about all of the calculation of motion with regard to force. So this subject is where the basic fundamental understanding about all of the component in the computer. So after this, each of the parts what we have learned in the topic in this chapter, you will learn in the subtopic, subject in different subject. For example, component of control. Later on, you will learn in control 1 and control 2. Component of input signal, the data presentation, or the data amplification. So that one will be learned in signal system next semester. So these are the things that later on all the subject will be linked together.